Okay, hello everybody. This is Dr. Patugi, CSC 750 professor, and this is our final recording for this semester. I hope you enjoyed the course. I tried my best to transfer good knowledge about the security, general knowledge about computer system security in this course to you. So in this session, we are going to solve the sample questions for the final exam. It's style-wise, it's exactly the same as what we have done for the two previous sample questions, and also the exam is the same style. So I didn't change. I don't want to change anything, so that I don't want to kind of expose you to new style or new manner, because this is an online course and it might not be easy to have everybody on the same page quickly. So style-wise, we are going to be doing the same thing. And the questions, it used to be a long time ago, I used to use a template like this, but now for online classes, so you don't see a template like this, but the questions are basically extracted from a template like this, and I upload them on Blackboard. So you have had the chance to go over the sample questions and answer them as a bonus question, as a bonus assignment. Of course, the deadline now is finished. Deadline was last night and last day, end of the day. So now we can talk about the question and try to solve them together. So again, like usual, you see a couple of multiple choice questions. I initially, when I started my career, not here, a long time ago, I used to define multiple choice questions to give students easy time to collect some scores, to be clear with you. But over the time, when I say over time, it means something about maybe 12 years teaching in different institutions, different countries, and I would say even different continents. Yeah, I realized that the multiple choice questions are in fact the toughest part. So I changed my mind. I said, okay, so I keep them as a toughest part of the exam, and I try to make my free response questions slightly easier. So the same thing. Again, in the first and second exam, I realized that many of you have lost at least one of the multiple choice questions, which means that, or some two, some of their three, which means that they are not as easy as I initially 10 years ago used to think, but that's fine. I know that the sample questions are basically the toughest part, and probably the reason is that items may ask from different topics. So at the same time, they may ask about a whole lecture or two lectures, and you need to have everything in your mind, and sometimes you need to be able to judge on them. That's why they are a little bit tough. But anyway, that's what it is. We have them in the sample question and also in the final exam. So let's get started with the first multiple choice question. Sorry about the noise. This is my youngest. Yeah, the first multiple choice question asks which of the following statement is not correct. Of course, you all know that you should pay attention to this part of the question. Is it asking about the correct item or incorrect item? Here, we are seeking an incorrect item. Item A says authentication works based on users' unique information. Of course, this is something that we discussed. We cleared it out that for authentication, user has to have something unique. That might be some knowledge, some unique knowledge that user has, like a password, or some unique characteristics that the user possess, like, for example, the pitch of voice or the construction of the face or the fingerprint, stuff like this. But that thing, at the end of the day, whatever it is being transferred in the information domain, and that's something unique. So this is correct. This item is correct, and is not the answer to this question. Item B says, a multi-factor authentication is technically a series of cascaded single-factor authentication that all should go through so that the user can get in. That's actually true. For multi-factor authentication, you first enter your username and password. That's the first layer. and then probably a code will be sent to you, which you have to have that access to that code and send it back to the authentication server. That's works as a second layer of authentication or second factor. But if you fail in entering any of these correct, you'll basically fail to get access. So you're basically authenticated, you're basically evaluated or assessed in a series of different layers, and each of them should go through successfully. So this item is correct. Item C, which is the answer of this question, says the process of establishing confidence in user identities that are presented electronically to an information system is called verification. So we have this process, we define this process as a part of authentication, and we called it the user registration phase. I'm sorry, we call it authentication. This is not the verification. This is the definition of authentication. Verification is something else. So, and the last item, item D, says functions and services subject to authentication can be either local or across the network, which is correct. For example, you open your laptop or your tablet, whatever, you try to log in. That login process is basically authentication. So you are trying to log in and get access to your local information. It's not over network. Your laptop or your tablet might not be even connected. Or you can, using your laptop, you can try to get connected to your mail server, which is somewhere else. Of course, it's not in your home, it's not in your estate even, maybe in some cases, but you access it over the network, and so you use the services and the functions. So any question about the multiple choice number 1? Okay, multiple choice 2 is asking again about incorrect item. Which of these statements is incorrect? And we start with A. Smart tokens often consist of memory with no processing capabilities. So if you remember, we've talked about smart token or token-based authentication, and we defined many different types of tokens. We talked about RFID devices or simple card that they have only a memory and an ID, which is somehow magnetically stored in that device, and that's it. But the very last type of tokens or physical tokens that we talked about was smart tokens, and we said that the smart tokens, unlike other type of tokens, they are not only memory devices. They have processors, and they can process some part of information, some information, basically like your credit card that you have, for example, a chip on that, and when you swipe it or when you insert it, it gets connected, and the processor now can process some information. So the main feature of smart tokens is that they're not only memory, they have processing capability. So of course, this is an incorrect statement based on this explanation. And if you want to know where I shared the whole screen, so you should be able to find them here. Let's say, let me search. Yeah. Here we say that smart tokens include an embedded processor, which means that they're able to do some sort of processing. They're not only memories. So item B of question 2 says computer-generated passwords are often not good as users have trouble remembering them. This is correct. We talked about the passwords user use, and we said that they might be often easy, or they might be repetition of the same password. They're all problems with the user passwords. But computer-generated passwords, the problem is there's even so complex, so that you don't basically have, most of the people don't have the capability to remember them. And they most of the time people end up saving them in a file, which is counterproductive. You don't want to save your password somewhere, because that's again, like I said, counterproductive. You don't want to expose it to someone. Item C says easily guessable password can be found using a reactive password checking method. This is correct. We talked about password audit, and we said that every time that the user tries to log in, we can check the password, and if the password is very easy, we can ask the user to change it. There might be even solutions for proactive password, easy password, let's say, avoidance. And that those are the rules that, for example, when you want to first define your password, the rules tell you that, for example, enter a password a minimum of 10 characters. That they include, for example, alphabet, numerical, and at least one of these special characters. So those are proactive password checking, and also we have reactive that works every time that you try to log in. So this is also correct. And item D, authentication using memory card is vulnerable to physical loss of the token, which is correct. We talked about this. So any question about multiple choice 2? So multiple choice question 3 is asking about the correct item. Which one is the correct item? Per mutual exclusiveness of roles in role-based authentication, role-based access control model, a user can be assigned to multiple roles at a time. Okay, this is correct. Environmental attributes are used for authentication processes purposes in ABAC, which is attribute-based authentication control and role-based authentication control models. So here we are seeking correct item. So this is incorrect. I'm sorry, I should make it clear that the item A is incorrect. Why this one is incorrect? Anyone knows? Let me get to the slide. It should be here probably, yeah. Yeah, in role-based, we were here. In role-based access control, here is the main slide. We talked about it. Here is, we define roles for each user, and we should make sure, because the roles might have different access options or access domains. For example, this role doesn't have access to this resource, but this one has. So it doesn't make sense if we assign a user 2 roles at a time. For example, if this kid has assigned role 2 and role 1 at the same time, how the system is going to eventually make the decision about the cases that this person or this kid wants to access this resource. Based on this role, we should grant the access, and based on this role, we shouldn't grant the access. So that's contradictory. So that's why this statement is incorrect. Per mutual exclusiveness of roles in RBAC, users can be assigned multiple roles, but not at the same time. Every single time they should be assigned a single unique role. Item B says environmental attributes are used for authentication purposes in attribute-based and role-based. So if we get back to the very initial slide that we talked about, here we talked about access control and we compared different methods. Only attribute-based access control, they use environmental variables or conditions. Role-based, they're not using environmental. So a part of this statement is correct. Environmental attributes are used for authentication purposes in attribute-based, but not in role-based. That's why this statement is incorrect. Item D says, the complexity of discretionary access control model with n users and m resources is O of m over n. This is not correct, because basically for implementing a DAC or discretionary access control, what you need is a table like this. I'm showing the table in the slides, in the right panel of my screenshot with you. You need a table with, let's say, m, here we said, yeah, with m columns, which stands for m different resources, and n different rows, which which are there because of n different users that you have. So the complexity is O of m times n. Basically, you would have a table as big as m times n. So the complexity is not O of m over n. Instead, it is O of m times n, which is not here mentioned. So that's why this statement is incorrect. And the only remaining item, item C, says, although a set of roles in RBAC model is supposed to be static, one can implement some levels of dynamism using family-based or a family of role-based access control models working together. This is correct. We mentioned this. We said that if you, we said that the roles are defined static, but if you want to make if you want to define some levels of dynamism, you can define family of roles and assign every user to a family, and then in future that you want to change the role, basically you assign the user to a different family. So you define two versions of a role. Role A with lower access version, role A with for example, higher access version, and then you assign them to different families and assign user to each of those families, so that you are basically making a sort of change in the role. Any question about multiple choice 3? Oh, yeah. Multiple choice 4, again, is asking about an incorrect item. Which item is incorrect? State-sponsored intruders are often those who conduct advanced persistent attack. This is clear. We talked about intruders, and we said that when we define different levels of intruders, we said that some of them are classes of intruders. We said that some of them are those who are state-sponsored, and let me see. It should be here. They have a very, it's here. Some of them might be state-sponsored, and they basically try to do advanced persistent attack, which makes sense because state might have problem with each other, and a state might have an enemy state, so they try to do something against. They try to implement the advanced persistent attack, and for that they try to conduct state-sponsored. They probably hire some intruders and try to conduct some intrusions. So this item is correct and is not the answer to this question. Item B says, after an intruder accomplishes their attack, they do their best to remove signs of their presence, which is correct. We mentioned this. Basically, if an attacker or hacker wants to intrude a system, they don't want the administrator to understand that they've been there as quickly as they breach into the system. They want to keep it hidden so that they can collect as much as data that they can, and then eventually at some point they may or may not release some signs so that the administrators understand that they've been there. So item B is correct. Item C says a low interaction honeypot is less costly as it implements not all layers of services. So we talked about two different types of honeypots, low interaction and high interaction, and we said that the we said that the low interaction honeypots basically are those that they mimic few layers of a real or origin server or service provider, so that the intruder can get some idea or can get full when the intruder works with that system, but they don't implement the whole layers because that's going to be costly. It emulates a realistic initial intrusion, but does not execute a full version of those services. Here is what we mentioned. It does not implement or execute the whole version. That's only because of the cost. Otherwise, you would have to pay the same price you've paid for the actual server to run your honeypot. Item D says firewalls can fully protect against internal and external threats. So the second part of this statement is correct, or let's say can be correct at least. Firewalls can protect against external threats, but they can less protect against internal threats. And the other thing that makes this statement strongly incorrect is this term of fully. There is no way you can guarantee in security domain that something is 100% guaranteed. So this item is the answer to this question. Any question or extra explanations about this? Okay. Let's get to the free response questions. In this sample question, it involved only two free response questions. Final might have more. But the total number of the questions is around the same thing, and the time of final, I guess it is 80 or 90 minutes. And again, like I explained before in my emails, in previous videos, I know that amount of time might not be enough for someone who just wants to start opening the slides or lectures. That's of course not enough time. That amount of time is enough for someone who has previously watched all videos and went through the resources and have a good knowledge about the content of the course. For some details, you may open a slides, or you may open the textbook, or you may open or watch again some of the videos. That's fine, but you don't have to. But you don't have time to search for something on that short amount of time. That's fine. That basically, I'm trying to say that I intentionally keep it not too long, just enough. So free response question, this should be 1 basically. Let me make it free response question 1, and this is free response question 2. Free response question 1 says, explain the concept of accuracy. Briefly explain why the concept of accuracy in biometric authentication makes sense. So, what was the accuracy initially? We said that in other types of authentication, for example, let's say user and password. If I enter my password correctly, I should get into the system. I should be granted the access. I don't want to enter my password correctly and the system says, "Oh, sorry, although your password was correct, but at this time we are not sure if we want to allow you." So 99, or let's say even 100% of time, if I enter my password correctly, I should get in and get access. But for biometric, that's not the case. Why? Because they are not working based on password. They are working, for example, based on the sample of voice pitch, or they work based on They authenticate me based on my voice. They authenticate me based on the pattern of my face, or the iris pattern, or the fingerprint. And all of these are, although they are unique to me, but after you convert them into digital information, there might be some variation. For example, sometimes I may stand in front of the camera with this angle, and another time I may use a different angle. And of course, patterns in my face may change when I change my position in front of camera, or I change the angle upside down, whatever. So this makes sense that we say biometric authentication, their answer, they do not technically return a yes/no answer for authentication request. Instead, they return a probability. They return a probability in the range of 0 to 100% or 0 to 1. And they say that, hey, this user that just tried to get access, his voice, for example, resembles the one of the voice we have saved before, let's say 90% or 95%. And the system makes the decision based on that percentage. For example, if I enter, if I register in a authentication system, and then that works based on voice, for example, and then later I give a second sample of my voice in order to get access, and my voice in the second time is 98% similar to what I have previously recorded, okay, the system most probably relies on me and let me in. But if my voice, for example, my throat has some issue, the second time my voice pitch is slightly different, and it only resembles 50%. In that case, the system doesn't allow me and says, most probably says, okay, please try again, record or say something else, or use a different method of authentication. That's why the accuracy makes sense. Accuracy means basically the percentage of times that the authentic user comes and we allow that people in. We allow that person in. And because of the fact that biometric authentication, they all work based on characteristics that might not be yes or no. There's a comparison, and that comparison might be some similarity between the range of 0 to 1. It makes sense that we say that we have accuracy in biometric authentication. Here's a kind of summarized version of what I said. Unlike other authentication methods, biometric authentication does not return a yes/no answer, since it works based on the finding similarities between the user's stored record versus the newly received one. It returns a similarity score in the range of 0 to 1. The closer similarity to boundaries, either 0 or 1, means that the authentication has accomplished with a higher confidence. So if it's 99%, it means that, okay, this person is a legit person. If it's 10% similarity, for sure means that this person is not a legit, which is called the accuracy. So any question about free response 1? So the next free response question is about this probabilistic curve that we've talked about it in the class. Again, this is about biometric authentication, and it says, in biometric authentication, this is the matching score. The question asks, briefly explain what would happen if what would happen to the shaded areas here, these areas that I mark in red in this, if the authentication accuracy improves, or if the authentication accuracy degrades. If the authentication accuracy improves, what would happen? This is basically the, let's say, a legit user. One of them is a legit user, and the other one is a fake user or authentic user. And what would happen if the accuracy improves? If the accuracy improves, these two bell-shaped curves, they'll get farther from each other. Basically, they may get something like this. I try to draw. They should be identical though. This is the case for A. If the accuracy improves, the two curves for legit user and authentic user versus unauthentic user, they'll get farther from each other. So the shaded area becomes less. Once the shaded area becomes less, we basically, our false positive, false negative degrades. And we would have less situations at which someone legit comes and we deny them, or someone fake comes and we allow them. And in most of cases, if the legit user comes, the system allows it. If a fake user comes, the system denies that person. This would happen if the accuracy improves. Unlike or in opposite, if the accuracy degrades, what would happen would be this. You would get, so let me write, this is for case A, and this is for case B. If the accuracy drops, this would happen. You would have a bigger overlap. And this overlap might be a bigger area. And basically your false positive and false negative gets bigger, which means that you would have more cases at which a legit user comes, the system denies, or a fake user comes, the system allows. These are fake, false positive, false negative. And again, for the case B that we say accuracy degrades, false positive, false negative increases, both of them increase, and basically our authentication system is working less effectively. Opposite, in the case A, the authentication system goes toward working more efficiently. So, and here is the kind of the summary of what I said. If the accuracy improves, two bell-shaped curves get farther and overlap less. The two shaded area will decrease so that the false positive, false negative decrease, and we would have our system working better or more effectively. If the accuracy drops, the two bell-shaped curves get closer and overlap more, which means the two shaded areas will increase. And again, you don't have to write that, but you can continue saying that as a result of that false positive, false negative increase, and you would have your system or your authentication system working less effectively or less efficiently. Okay, I'm done with this question, and I'm open to questions about multiple choice question 2. Any question about multiple choice question 2? Okay, so in the Blackboard, if you have answered the multiple choice question, there was another question which I don't think is required to be discussed here. It was about any feedback about the course. So if you have any feedback, you can just enter it there, or you have entered there, or you just could leave it blank. That's fine. So I'll be uploading this video to Blackboard, and you have received an email about the final exam that it's gonna be open to you starting next week. You would have a couple of days access to that, but once you open the exam, you should finish it in the given amount of time, which I guess is 90 minutes. Or let me make sure 90 or if it's 90 or 80 minutes. Anyone remembers? What did I say in the...
I thought it said 90.
Okay, yeah, thank you. Yeah, it's 90 minutes. So if you open it, yeah, it's the final exams will be available to you. You need your review lectures 4 and 5, and then it's yeah, it's 90 minutes, and the exam is Monday 8th, 8 a.m. to Thursday, May 11th, 8 p.m. So any question about anything, basically?
Sir, I think there is another pre-response question number 3, like a matrix. We have to write down the matrix.
On Blackboard, there is a like I said, there is an extra question on Blackboard, but that's about the
not the Blackboard, not the suggestions, but there are 4 pre-response questions in the test. There was.
Thank you. Yeah, it's here. I just forget it. Yeah, you're right. Thank you, Muta.
Thank you, sir.
Yeah, I appreciate. So this is basically the free response question 3. You're right. It was in the last page. I didn't see that. So this question is asking about how converting this matrix. So let me okay. This is the question. Write the matrix representation equivalent of the following discretionary access control system, which is represented in a linked list format. So basically, this is a DAC, discretionary access control, and we said that you can save a DAC database as a table or as a linked list. Here we are given the linked list and we are asked to convert it into a matrix representation, which is basically a tabular representation, which is very easy. If you remember, in DAC, we said that we have a number of users and a number of resources. So you can put them in a table. Now, users can go to rows. It's up to you, but it would be easier to put the users in rows and the resources in columns. And here is a solution to that. Yeah, we have defined, if you look, we have file 1, file 2, file 3, file 4. So we have only 4 different resources. So file 1, file 2, file 3, file 4, they went all to the columns. And then we have user A, user B, user C, user A, B, C here, 1, 2, 3, they are basically A, B, C. And then now for every cell, we need to say user 1, file 1. We see that or user A, file 1. User A has access to file 1, and it's the user A is the owner. So we put the owner here in this cell, which whenever later we refer to this table about making decision if the user A is allowed to access file 1 or not. When we see this owner, we understand that, hey, user 1 or user A is the owner of file 1. So user A should have the full access to this file, to this resource. User A, though, he or she doesn't have any access to file 2. That's why in this cell, which is in the junction of this column, file 2, and this user A or user 1, we put nothing, but we leave it blank, which basically means that user A or user 1, he or she doesn't have any type of access to file 2. For file 3, again, he is owner, so he has read and write access. For user B, file 1, user B only have read access to file 1, so we put R here. File 2, user B is the owner, so we put OWR here. For file 3, user B has the write access, And for file, he or she has only the read access. The same, we look at these lists and we decide about every single file, how the user C or user T is going to access them. And like you see here, we have file 1, file 2, file 3 is not here. That's why we leave this cell blank, because user 3 or user C is not supposed to get any type of access, is not supposed to get any grant to access file 3. So we leave this blank. And again, similar what we have in the previous question, if you look, we are talking about m times n, here 4 times 3, a table of 4 times 3. So the complexity is m times n. Here is a different representation of that. I just wanted to keep it as a table. So you say user A, user B, user C, file 1, file 2, and then you can write the same table. So you may get the same question in opposite direction. Here is the table converted into linked list, which is very easy, because you just need to link whatever user X is supposed to access, and then you say read or write or owner. That's it. So the conversion is very easy. It's just, as I mentioned in the videos, it's just a matter of how you store the data. It doesn't impact the actual authentication, let's say, functionality. It only make change in the amount of memory that authentication system needs. But which is a very good thing. If you save them as a linked list, you only save those you basically save some of the cells. For example, the 1, 2, 3 cell. In this example case, we have 3 cells with blank. And instead of 12 cells, if you count here, we only have 9 different elements. So basically we are saving some memory, which is a good thing. But in terms of authentication functionality, they're working the same. Any question about this?
In case, if we have to go backward, like a linked list, if we have to make a linked list from the matrix, that means in the blackboard, writing those linked lists will be, I don't know how.
You do it this way. If I ask, for example, you say user A, let's say, if you want to write it as a linked list, you say user A. I understand what you're asking about how to draw something in Blackboard. That's your question.
Yes, sir. Yes, sir.
So you say user A, let's say file 1, for example, you define something for yourself. You say, let's say, I'm trying to convert this first row in a linked list. You say owner, and then you link it. In Blackboard, you may see something like this. And then you say file 3, again owner. That's it. That's what we have for user 1. You put dot or whatever, that doesn't matter. User, for example, B, file 1 is just the read access, and then file 2 is the owner, and then file 3 is write access, and file 4 is only read access. Something like this.
But for file 2, it is having owner, reader, and write access also, right?
You can owner, basically when we say that, you can put that, you can say that's also correct. You can say read/write/owner.
Okay, thank you, sir. So normally owner means he got it with all the rights, but
yeah, owner, I'm assuming that the owner, yeah, you're right. In some cases you have the owner but you don't allow the owner to, for example, delete the file. For example, in corporations, that might be the case. I'm assuming, but that might happen in few cases, I would say. That's why I'm assuming that the owner has all accesses. But according to this table, if we want to be accurate, we should say, for example, owner, read, write, and owner.
Yes, sir. Thank you, sir.
Thank you for asking, Muta, for this question and for the question you asked. And you can put it this way, or any other question that it may need something you draw and upload on Blackboard. Of course, you can't draw things on that type of questions that I define, because I define them as essay. But you can just use a convention, a style, and explain, okay, here I mean this by that. Is there any other question? Okay, I'm going to stop recording.